Welcome to part 16 of our series on building a Zelda-like game in Phaser 3. In this video, we'll start working on interactable items by creating the pot and chess game object classes. We'll set up their collisions with the environment and the player, laying the foundation for interaction mechanics. If you're new here, this is part of a full series where we create a Zelda-inspired game from scratch. Check out the playlist link in the description to start from the beginning. Alright, let's jump in and start adding interactive objects. Now that we've added enemies to our game, and given the player something to fight against, let's shift our focus to another important aspect of gameplay, interactable items. Interactable items, like chests and pots, add depth to our world, rewarding exploration and making the game feel more dynamic. These objects will allow players to collect useful items, break obstacles, and even uncover hidden surprises. In this section, we'll learn how to create and manage interactable objects, handle player interactions with them, and integrate them seamlessly into our game world. Let's jump in and start by creating our first interactable item. For our interactable items, we're going to focus on creating our base classes first, and then we'll work on adding in our collisions and giving our player the ability to interact with them. To get started, let's go into our code. Under our game objects folder, let's make a new subfolder. We're going to call this objects. So now in our objects folder, we'll make a new file, and let's call this pot.ts. Let's export out our class. And for our class, let's extend our Phaser Physics Arcade sprite. Now at the top of the file, let's add in our import. So we'll do import star as Phaser from Phaser. So let's add in our constructor. And so for our constructor, we're going to expect a configuration. So we'll do config, and we'll call this pot config. Let's define that type at the top of our file. So do type, we'll do pot config. For this, we're going to need our Phaser scene that we're adding our game object to. So we'll have Phaser.scene for our type. And now we want our position of where we want our game object to be at, so we'll add in position. So now back down our constructor, let's first grab our scene or position from our config. So we'll do const, we'll do scene, position, equal to our config, and now let's do super, pass in our scene. We'll do our position.x, our position.y, and now for our asset keys, we want to use our pot asset. And we'll do 0 for our default frame. So now in our game object, we're going to want to store the position of where our pot is placed in our game. And this is going to be important later because when our player breaks one of our pots and leaves a room and they go back to it, we want to regenerate that game object back in that original position. And so we'll want to reuse our existing game object and not have to recreate it. So now after our super call, we want to add our game object to our scene. So we're going to do scene, we'll do add existing this. Let's enable our physics, so we'll do our scene physics, add existing, this, and then finally we'll update our origin on our game object, so we'll do this, we'll do set origin, and we're going to set this to 0 and 1, and then we want to make our game object immovable, so then that way when our player runs into it, we won't move it around our scene, and so we'll do set that to true, and now we just need to update our position. So for our position, let's look for our x value, this will be our position.x, and for our y, this will be our position.y. So now that we have our new class, let's jump over to our game scene and we should be able to create an instance of it. So after we create our enemies, let's create our game objects. So let's do a new pot. For our configuration, we'll pass in this scene. And now for our position, I'm just going to copy our property here from one of our enemies. We'll go ahead and paste that. And now for our x value, we're just going to go ahead and add 90 to this. And for our y value, we won't add anything to that. And then finally, let's import in our class into our file. And now if we save, if we come over to our browser, we should see our new game object is visible in our scene. So currently, because we haven't added in our collisions, our players are able to move through our game object. Now that we've created our pot game object, let's move on to create our chess game object. So for our chess game object, let's go into our code. Under our objects folder, we'll make a new file. Let's do chest.ts. I'm going to go over to our pot.ts file. Let's copy our code. I'm going to paste it over here. For our class name, we'll update this to be chest, and we'll update our configuration to be chest config. So now for our chest that we add to our game, we're going to add 2 additional properties we're going to pass through. The first one is going to be requires boss key, and we'll have that type be a boolean. And then for our second property, we're going to do chest state. And we'll make this optional, and then we'll make a new type for this. So now for our chest that we're adding to our game, typically in Zelda games, there's 2 types of chests. There's the small chest, and these typically include items like rupees, keys, the map, the compass for the dungeon, and heart pieces and different things like this. And in the dungeons, there's usually one big chest, and this big chest will usually have an item that'll be helpful to you in the dungeon for either overcoming traps, puzzles, or even the boss itself. And this chest itself usually requires the boss key in order to open it up in our game. And so that's what our requires boss key property is referring to. And so how chest state will be used is typically when our player enters a room, there might be a chest that's immediately visible that the player can go and collect. There might be a chest that's hidden, and that requires some type of puzzle to be solved or task in order for it to show up in the game. And then if we open up a chest, we need to keep track of that state, so in that way our player can't reopen it again. And then our state will determine which texture we're using when we render out our game object. So to define this chest state, let's go into our code, let's go into our common, and then we'll go into our common.ts file. Let's do export const, let's do chest state, and we'll do as const. And now for our object, we'll have three properties. We'll have hidden, revealed, and open. Now for our object, we'll update our keys to have the same value. And so we'll have hidden, revealed, and now open. Now we want to define our type. And so if we open up our common and go into our types.ts, we're going to do export type, do chest state. And this will be equal to our key of, our type of, chest state. So back in our chest.ts file, so now back in our chest class, let's update our import so we have our chest state. So on our class, we're going to want to keep track of our two properties for our state and isBossKeyChest. So first, let's do our state. We're going to set that equal to our chest state. And now we'll have another property. We'll do isBossKeyChest. And this will be a Boolean. So now for our asset key, we want to use our dungeon objects asset key. So this is referring to a sprite sheet that has a variety of objects will spawn in our dungeon. So if we go under our public assets folder, if we go under images, let's go into our levels, our common, and then if we open up our dungeon objects PNG, we'll see the sprite sheet has images for things like our buttons, our small chest, our large chest, and then our doors, and then our pressure plates in our game. So now for our configuration, we need to specify which frame we want to use. So depending on if this is a boss key chest or not, we'll show our big chest or we'll show our small chest. To keep track of that, let's make a new variable, do const. We're going to do asset key. We're going to set that equal to our config and requires boss key. And so if that's true, we'll use our chest frame keys and then we'll do our big chest closed. Otherwise, we'll fall back to our small chest. So let's do our chest frame keys and now I'll do our small chest closed. So let's pass our asset key into here. And instead of doing asset key, let's call this frame key. One other change we'll do is for our chest, instead of doing a sprite, we're just going to do an image since we won't have any animations for this game object. So now we just need to update our properties on our class. All right, we'll start off with our chest state. So we'll do this, we'll do our state, and that's going to be equal to our config and our chest state. And we'll have a fallback if it's not provided, then we'll have our chest be hidden. Now we want to set our isBossKeyChest property. We're going to set that equal to config and requires boss key. Now that we've created our new class, let's create an instance of it in our game scene. So if we go into our game scene, after we create our pot game object, I'm just going to copy this. We're going to go ahead and paste it. And let's update our reference. We're going to use our chest class. Now for our position, we'll do -90 for our first chest. And we'll do requires boss key. And we're going to set that equal to be false. Let's create one more instance, and we're going to set requires boss key to be true so we can create our big chest. And for our position, we'll just update our height, and we'll do -80. All right, so we save and come over to our browser, we should see our two new game objects. So one thing we'll want to do is we're going to want to update our body on our big chest, so then that way it matches our sprite size. So if we come back to our chest class, after we update our configuration, let's update our physics body. So we're going to do if this is a boss key chest, then we want to do this, our body, and we'll do as phaser physics arcade body. We'll want to call set size, and for our size, we're going to do 32 pixels by 24 pixels. And we'll want to update our offset, so we'll do set offset, and we're going to do 0, and then we'll do 8. So now if we save and come back to our browser, we'll see now our physics body's been updated to match the size of our chest here. One other thing we'll do for our chest class is we're going to add a new method to allow us to open up our chest. And then that way we can make sure we have the right frame associated with our chest when we open it. So let's do public, we'll do open. For this method, we won't return anything. And so first we're going to check our chest state. So we'll do this. If our state does not equal chest state revealed, then we want to go ahead and return early. So if our chest is already opened or if it's hidden, we can't actually open up our chest, and so we won't run any of our logic. First thing we'll do is we'll update our state, and so we'll do our chest state, and we'll set it to be open. And now we need to figure out which frame to use for our texture. So let's copy this line of code here. We're going to paste it. And so if this is a boss key chest, now we want to do our big chest, and we want to use our open frame. Otherwise, we'll use our small, and we'll use our open frame. So now we can just call this set frame, and this will update the frame we're using from our asset. So we'll do our frame key, and let's save. So what we're doing in our game scene is after we create our chest, let's call our open method on both of these. And once we save, what should happen is our chest should still be in the state where we show that our lid is closed. Reason for that is by default, our chest state is defaulting to our hidden state, and so we need to provide a custom state if we want to be able to open our chest. So if we update this, we'll do our chest state. Let's do our chest state, and let's do revealed. If we save, now our small chest should be opened. And if we copy this and we change this to hidden, let's paste this down here. Now we should be able to open our big chest, and our little chest should still be closed. So now we've tested our logic works, so let's remove our chest state, and we'll remove our call to the open method. Next, for our game objects, we'll want to enable collisions between our player and our game objects and our enemy and our game objects. For this, if we jump into our game scene, let's start off by creating a group to keep track of all of our game objects that we'll collide with. At the top of our class, let's call this blocking group. We're going to do phaser, we're going to do our game objects, let's do our group. So now down here, we'll do this, we'll do our blocking group, will be equal to this.add.group. And now for our children, let's add in our pot and our two chests. So we'll grab our objects from here, and let's move our code inside our group. Now that we have our game objects in our group, let's come down to our register colliders method, and now we'll add our collisions between our player and our blocking group. So for that, we're just going to do this. We'll do our physics. Let's do add. We're going to do a collider, and now we'll do this.player, and we'll do this. We'll do our blocking group. Let's add in our callback for when our collision happens, and for the time being, we won't do anything. But if we save, we come over to our browser. Now if we move our player and we come up to our chest game object, we'll see our player is now blocked by it. We're not able to move through it. Same thing for our big chest and for our pot game objects. All right, so by using a collider instead of overlap, what this allows us to do, this allows us to rely on the built-in physics to allow these game objects to collide together, while our overlap allows the two physics bodies to overlap with each other. And so typically when we collide with our game objects, this is going to apply a force to the game object and have it move. But because we called set immovable on our chest and our pot, so as an example, if we come in here to our chest class, if we go to where we have set immovable, if we set this to be false, now what will happen is when we collide with our game object, we're able to push it, and we're able to apply our velocity to that game object and then move it off our scene. And so it's important for when we have these objects that we don't want to move, we want to call it set immovable and set that to be true. So now that we have our collision between our player and our blocking group, we want to do the same thing for our enemies. So we're just going to copy this, we'll paste it, and now we're going to change this to be our enemy group, and then our blocking group, and let's just add in our properties for our arguments here. So we'll have our enemy, and then we'll have our game object that we interacted with. Up here, we'll have our player, and we'll also have our game object. All right, so if we save, let's come back to our browser, and what we should see is eventually our enemy game objects should run into one of our objects, and we'll see that they're stopped and they're not able to move through it. That's it for this part of the series. If you found this helpful, be sure to hit the like button. It really helps out the channel. And if you're following along, make sure to subscribe and turn on notifications so you don't miss the next video. If you have any questions or want to share your progress, drop a comment below. I'd love to hear from you. All right, thanks for watching, and I'll see you in the next one.